Think you're special? One of a kind? We agree. The way you pursue your digital ambitions is unique to you. And so is your appetite for digital risk. Whether you're hyperconnecting your ecosystem, empowering a distributed workforce, rapidly leveraging cloud, IoT, AI, or other new technologies, RSA is here to help you manage digital risk your way at every stage of your journey. So go ahead, be you.
Hello, and welcome to Intelligence Sharing for Critical Infrastructure Resiliency. If you're joining us live, our speaker is in the Slido discussion answering your questions right now. For audio technical issues, you can click the technical support button below. I'd now like to turn it over to John Lee for the presentation.
Hi, good morning from Singapore. Today my talk will be on information sharing and how we can use it to increase the resilience of our critical infrastructure. As we know, we live in a digital connected world, and more so amidst this pandemics. We all share information in our daily lives and in business as well. So governments and military have done so for the longest time. So intelligence sharing is crucial. It helps us to confirm our hypothesis and act in a certain manner that we can protect our interests and further our objectives. So there are three topics I'd like to cover. I will start with operational technology and explain why this is important to ensure its security. Next, I'll talk about the importance of using best practices and a structured approach to secure operational technology, and ending with a case discussion on information and intelligence sharing. So operational technology, as defined by Gartner, these are the hardware and software that detects or cause a change through the direct monitoring and control of physical devices, processes, and events in the enterprise. They keep our industrial processes from running, such as our utility and power stations, smart factories, building automation systems, oil and gas installations, healthcare, transportation, our baggage and handling systems at the airport, water treatment plants, and many more. OT, or operational technology, is the technology that interfaces with our physical world. And that includes ICS, or industrial control systems, supervisory control and data acquisition, or SCADA, and distributed control systems. Now, ICS comprises of computers, both mechanical and electrical devices that perform automated or semi-automated control of equipment in industries. And these are used by critical infrastructure to control its operations. ICS have embedded cyber devices that operate the industrial processes. So example, a boiler has a sensor that controls the temperature to prevent overheating in the plant. So the sensor is linked to a computing device for monitoring and control. So at the moment it detects a rise in temperature, it will take steps. The safety systems will turn off the boiler. So another example of operational technology is our ships at sea, where before the navigation was using manual charts, but now GPS and electronic charts are used to control the navigation or the route of the ships. So therefore, it cannot be overemphasized, this extreme importance of critical infrastructure, that they keep on going as they provide services to the country, our industry that fuels our economy, and ensure that our daily lives continue to have the basic needs. So the impact of a breach to critical infrastructure can disrupt our lives and cause physical harm to our citizens, and impact our financial systems and the economy. So this is a diagram of the interconnected world in industrial control systems. So in the 70s and 80s, ICS, or industrial control systems, are air-gapped. They are not connected to the internet. You don't find cyber breach that often. So security breaches are through physical means. However, OT systems back then were built to be safe and reliable with the required functionality. But we are seeing more and more interconnectivity from the 1990s. So with the integration of IT components, this allows the ICS, or industrial devices, to leverage software to drive data collection and analysis. resulting in smarter machines. But the flip side is that vulnerabilities are introduced. Malicious actors can use the IT network to gain access to critical OT assets. Security was not a concern in the past due to the separation of the IT and OT network, but it has become an increasing concern now because of the numerous breaches that have happened in the last few years, in the last 10 years. So in 2014, German steel mill cyber attack occurred where adversaries used spear phishing tactics to capture user credentials. So the captured credentials was used to connect to the OT network through the business or IT systems. So massive damage was caused, resulting in the blast furnace being shut down. So some of the attacks on critical infrastructure include the Iranian nuclear plant that was infected by a malware that specifically targeted a brand of equipment that was being used by the facility. And that impact was that PLCs and connected centrifuges were destroyed, thereby setting back their nuclear program. So another example, in 2012, a targeted malware was used in an attack on the Saudi National Oil Company. The Wiper malware infected 30,000 workstations and deleted the files, rendering the workstations non-functional. So another attack on the Ukrainian power grid happened in 2015. Spear phishing emails was used to load the malicious payload known as the Black Energy malware. The SCADA system was compromised and IT infrastructure systems was destroyed, thereby impacting more than 200,000 homes who were left without electricity. So imagine if that happened in our country, so that will have a disastrous consequences. So in 2016, another blackout occurred in the same country, likely to be caused by the same perpetrators. So another example, in 2017, that impacts safety instrumentation systems of a Saudi petrochemical plant, which was the target, and that caused the plant to shut down. So attackers are learning and adapting their methods to target critical infrastructure. They are using sophisticated methods and tools. According to MITRE, there are 94 APT groups that were largely responsible for all the high-profile attacks. There was an alert recently this year by the Cybersecurity and Infrastructure Security Agency, or CISA, about a natural gas facility in the US that was hit by ransomware. The delivery of the payload was through an attachment from a spear phishing email. So the ransomware payload caused a loss of availability on the OT assets, such as the HMI, historians, and polling services. As the data on the OT network could not be read or aggregated from these devices, it led to a loss of visibility by the human operators. So this led to a 2-day shutdown of the plant. So another example of an attack on critical infrastructure, Israeli water facilities suffered a cyber attack this April. So 6 plants were targeted. Data was wiped out, and one of the plants had to shut down because a pump was compromised. So the danger here is if the adversary could compromise the systems that control the level of chlorine added to the water, it could lead to poisoning of the consumers. So cyber attacks on critical infrastructure is one of the means that nation-state actors, they will use this to soften the target and pave the way for further attacks that may follow. So in a survey by Ponemon Institute in 2019, out of 701 respondents, so OT cybersecurity is lagging behind its enterprise IT counterpart. 90% have suffered at least one attack in the past 2 years. 60% are concerned that an attack against the infrastructure would have huge impact to operations. And 62% mentioned asset identification, both OT and IT, is important. So OT assets are crucial, and its protection needs to be prioritized. 80% felt that sharing threat intelligence is important, as this will help increase resiliency. So I'm going to cover this model, the Cyber Capability Maturity Model from the Department of Energy. So given the vulnerabilities that we have just heard and the maturity level of OT operators, which is lagging behind the enterprise IT, The very first step we need to do is to understand the areas that your organization needs to focus on to protect the infrastructure. So objective of using this model is to do an assessment to identify the current state of OT security. And the gap will be the difference between where you need to be and its current state. So in order to achieve the future state, you need to have the capabilities, and these are defined using the model to do your assessment. And the value of such a model is a framework, and there are many models out there. So one of the benefits of using this model is sharing of best practices and information. You can benchmark against other organizations within your sector, strengthening your organization capabilities with the assessment. You know the areas that are weak, and managing risks by prioritizing areas that you need to focus on in order to achieve your future state. So the assessment is done and involves evaluating 10 domains. So the domains presented on the left-hand side are risk management, asset change and configuration, identity and access control, threat and vulnerability management, situational awareness, event and incident response, supply chain dependencies, workforce management, cybersecurity architecture, and cybersecurity program management. So in the assessment, each of the domains will have objectives and practices related to the objectives. So the evaluation or assessment will be on the practices that are currently being performed in your organization. So the practice will determine the current maturity indicator level for each objective within the domain. So for example, the threat and vulnerability domain objective 2 has given there. Practice D is being performed in the organization, which means threat profile. For the function is established that characterizes potential threat actors, motives, intent, capabilities, and targets. So in order to achieve practice D maturity level, the organization need to meet the prior practices A, B, and C, which is identifying internal and external sources of threat intelligence, gathering and interpretation of these threat information, and implementing controls to counter threats at different levels among relevant to the organization. So the model will determine the level of preparedness of the critical infrastructure in dealing with the OT IT threats. So it is a framework for critical infrastructure protection. So it is also important to recognize that there's no silver bullet, but this is one of the ways to increase OT cyber resilience. So this example is the assessment for the risk domain is risk 1D. So that refers to objective 1 and practice D. Practice D is objective 1 is manage cybersecurity risk, and practice D is that risks are recorded in a risk register. So as with the threat example which I gave in the previous slide, to attain practice D, preceding practices A, B, and C need to be fulfilled, which is you need to identify cyber risks and document down the risks. Risks are mitigated, accepted, avoided, or transferred. And you need to have regular risk assessments performed to identify risks. So we know that legacy operational technology is insecure. So in recent years, more and more manufacturers are working to include security elements, given the increasing connection to and use of IT technologies in OT to drive performance and productivity. So to secure operational technology, there are two things that are needed. First, you need to assess the current industrial systems operating environment, understand the gaps. So we discussed the C2M2 maturity model. So using that model allows you to identify focus areas to help prioritize its remediation. Second, sharing or receiving threat intelligence, both internal and external, helps in increasing maturity and managing risk. So I will touch on some of the vulnerabilities of ICS and cover the intelligence cycle before going into the case discussion. So in a research by ABI in 2019 on utility cybersecurity, it was mentioned that by 2023, connected utility infrastructure will double. So the increased connectivity will expose the companies to cyber threats. So industrial IoT devices such as smart meters, your smart grid, your energy efficiency management systems will be used. So this digital transformation will see many other critical infrastructure sectors adopt technologies as well. So that enables smart infrastructure due to increasing competition and changing consumer needs. So some of the vulnerabilities that we are seeing are poor design of the OT infrastructure. So these do not consider security. It is needed to have a security architecture in OT environments because the landscape is diverse. There are multiple vendors, equipment, and devices, each running their proprietary protocols. So having an architecture view will help decision makers understand the trade-off in making architectural choices that will impact security and allow you to implement controls to compensate for the lack of the security design. So initially, the OT networks were safe due to physical separation, but we cannot assume that given the digital transformation. So it's best to segregate the ICS networks into enterprise zone, control zone, and field zone. And strong boundaries must be established between the zones. So this segregation of the network in the OT infrastructure follows the principles of defense in depth. So industrial control system protocols are also not secure. So they are used for connecting devices and systems among the different vendors, such as a generic HMI solution can connect to a Siemens or Rockwell Automation PLC. So from a security perspective, these protocols also are unencrypted and they do not have integrity checking, so which leaves them open to replay and manipulation attacks. And it makes it very dangerous because more and more of these systems are getting connected to the internet, and they are available via the internet, via modem for the vendor to provide remote support. So another vulnerability is identity access management. So it's important because most of these we see in the IT world, they have good control systems in identity access management, but not so for in the ICS world. So it's important to prevent unauthorized users from accessing trusted systems and preventing your authorized users from making unauthorized transactions, whether intentional or unintentional. So another vulnerability we are seeing is devices in the field zones have weak authentication, and this runs into dangers of adversaries that can do a man-in-the-middle attack. So we are seeing that due to Industry 4.0, automation will increase and brings more interconnectivity between the IT and OT networks. So it's important now to take steps to secure your industrial network and your applications. So most of the networks are designed following the Purdue model architecture. So this was developed to segregate industrial networks. So it's one of the good OT cybersecurity practice. So the field zone is where level 0 and 1, and it contains physical processes and devices that are used for sensing and manipulating the physical processes. So you'll find sensors, analyzers, actuators in this zone. So the time frame for connection is in terms of milliseconds to seconds. And IT cybersecurity solutions rarely ever apply in this zone. So control zones are level 2 and 3. So these systems such as SCADA, HMI, and DCS. And the time frame is in minutes. Manufacturing operation systems at level 3 manage your production workflow to produce the desired products. Requirements for control zone emphasizes safety and reliability. And these devices in this zone are not updated frequently because the network in OT, you cannot stop a process from, the operations will be impacted if you stop a process to update. So few cybersecurity solutions from the IT world can be used in this zone. So level 4 is the enterprise or IT zone. And this is where the business systems manage the business-related activities for the industrial operation. So since IT solutions do not really apply to OT networks, there's often a lack of visibility in the OT network, and that can pose challenges. You cannot protect what you don't see. So of late, there are good OT network monitoring solutions that can identify the assets on the OT network. This will help OT operators to assess the threats and vulnerabilities of the connected assets that are being identified using the C2M2 framework that we discussed before. So next, I'll touch on intelligence sharing before going into the case discussion. So intelligence, as we know, is important. It can help the organization to detect, protect, and respond to threats. There are two cycles that I'll cover, or two models, the intelligence cycle and the F3EAD cycle. And I will sum it up because both can interoperate together. So generally, you have intelligence requirements at the strategic, tactical, and operational level. So the strategic element looks at who is targeting your organization and why they are targeting your organization, and also where these threats are coming from. The tactical element looks at details of the threat and the timing that these threats are executed. So operational aspects look at how the threats can breach your target. So the important thing is that threat intelligence must be actionable so that it can increase cybersecurity resilience. So the intelligence cycle starts with a mission. So planning and setting the direction to achieve the mission is your first step. And that includes identifying intelligence requirements based on your needs. So data is collected next from various sources. This includes acquiring, provisioning of the information to be used in the next step. Collected information is then converted into a format that you can use, or the analyst can use for processing. And the next step is production of the, which involves analyzing, evaluating, interpreting, and integrating all the information that you collect into finished intelligence products, which is disseminated to the constituents or to your stakeholders. So this cycle, F3EAD, is used by military and organizations. So it's an alternative to the intelligence cycle. It combines operations and intelligence. The first three steps are operations, and last three steps are intelligence phase. So getting actionable intelligence from the partners and peers can help your security operations find, fix, and finish the incidents. So if a threat is found, the organization needs to respond to the threat. There should also be playbooks to deal with known and unknown threats. Solution deployed is to ensure that the threat is remediated. So this is the operation phase. So following this phase is the intelligence phase. So this is where information can be exploited and analyzed for utilization by the community. So information collected from the incident will be enriched so that it's contextualized and may be shared with the wider community and stakeholders. So intelligence requirements can be strategic, tactical, and operational, and combining both the intelligence cycle and the F3EAD cycle covers the three categories of threat intelligence. So threat intelligence needs to deliver value. That's the most important thing. So it must be contextualized to your threat profile. So every organization have a threat profile. So we talk about the strategic, tactical, and operations needs of the organization. So articulation of the impact of the threat to the consumer or to you as a consumer of the intelligence is important. So it will help you in decision-making and assessment of the risk from the perspective of the organization. So to sum up, good threat intelligence can help organizations prevent, detect, and respond better when the threat occurs. And a recommended action to take is just as important, if not the most important. So I'll end this with a case discussion on intelligence sharing in the ISAC, or the Information Sharing Analysis Center. So there are various sources of information that is shared with OT ISAC. So the analyst will take this information and contextualize it into relevant intelligence. And the information can be from public and private sources, governments, CERTs, threat intel vendors, dark webs, regulators, and other partners also share information about incidents and vulnerabilities. So member sharing is important because they provide use cases for the other companies within the sector. So members can create forums for further threat discussion. Requests for intelligence, or RFI, may be created by members to request the OT ISAC analyst for further information. So these can be general or prioritized intelligence. GRF supports up to 10 ISACs and ISAOs. And cross-sector sharing also helps to paint the overall threat picture. So OT-ISAC members are provided access to a secure portal, and it can be accessed through the web browser or the mobile app. And members participate in events such as workshops, training, and seminars to share best practices and receive information on OT and IT security threats that are relevant to their sector. So OT-ISAC analysts also conduct monthly threat calls for its members. And they talk about topics of interest to the members, as well as receive feedback from the members, because I think that is the most important thing, to have a vibrant communication between the ISACs or between the analysts and the members, so that members can bring out the areas of concern that they see in their OT environment. Members also engage in discussions among themselves. Sharing of threat information is following the traffic light protocol. And TLP rate is where sharing on the call, information shared cannot leave the group that it is shared with. And TLP amber is where sharing between the parties on the call can be shared with members of the organization or service providers that are helping them with the OT security, but not outside this group. So TLP green is sharing with the OT-ISAC community at large. TLP white is sharing with the public. So next, I'll run through the OT-ISAC incident sharing process. So the entire process can be completed within 1 or 2 days, depending on the criticality of the threat. So members that receive early warning of the threats can take the necessary action to protect themselves. So it starts with a member sharing information about an incident or threat with the OT-ISAC. So that may include details of the incident, TTPs, and IOCs. The information shared is vetted by our analysts, contextualized and anonymized. No attribution will be made to the member who shared the incident, as the details are anonymized. The analyst may contact the member who shared the information to collect more details or clarify the incidents. So as you can see that the information that is shared is carefully vetted, because we do not want to spread false information. And intelligence really that is vetted is then disseminated to the OT-ISAC community. So and if relevant, to the GRF cross-sectors community. So next, I will talk about what are the threat intelligence. So this is the pyramid of pain that was introduced by David Bianco in 2013. So it measures the usefulness of threat intelligence, and it lists down the type of indicators that are shared. So from bottom to top, it also defines the effort of the adversary to change their tactics. So for instance, your hash values and IP addresses at the bottom. So these are easy for the adapter, for the adversary to adapt and change to deceive the defenders. So if you block an IP address that is malicious, the attackers can also spoof another IP address. And as we go up the chain, it becomes more and more difficult for the adversary to adapt and change their methods. Domain names used by adversaries also have an active life before they are discovered and blocked by the defenders. So the higher up the pyramid, it becomes harder for the adversary to adapt. So if you block their tools, it will force the attacker to look for another, causing an amount of pain to them. At the top of the pyramid is the TTPs, tactics, techniques, and procedures. So these are the behavior of the attackers. So if you detect and block the TTPs used by the attacker, you force the adversary to modify their methods and behavior. So this is the most effective. OT-ISAC members can share any of these indicators together with the details of the incident, impact information, actions taken, and mitigation strategies. So I end with a case study. It's an example of an incident shared by a member of the ISAC. So a member reported an incident that was uncovered during a security assessment of their infrastructure. So internal server that was not authorized to external communication was found trying to do so. So further analysis was done, and a compromised application on the server was discovered. So that application was trying to send a beacon from the infected server to an attacker command and control or C2 machine. So this is a common attack method used by adversary who will install a Trojan on the victim's machine, who will call back to the C2 server that will distribute the malicious payload, which can be malware or ransomware, and drop it on the machines of the victims. So in this case, the attack was stopped and the compromised application was stopped, was cleaned. So mitral attack tactic used is command and control. Techniques used are exploitation of commonly used ports 80 and 443 using a command and control protocol. So mapping to the F3EAD cycle, starting with detection of the suspicious traffic through the firewall logs. The offending application is removed with restriction placed on the victim machine before accessing the internet. So IOCs of the incident was gathered with members' details anonymized. Threat alert was produced and disseminated to the community following the TLP protocol. So this prevented the same threat from exploiting other members. So I'll end with key takeaways from this talk. So in the short term, you need to understand how the IT and OT department function in your organization. So in the poll that we conducted, there may be some that express joint ownership of OT and IT in their company concerning security budgets and management. But however, IT and OT security needs have to be holistically considered. So both IT and OT must work seamlessly together. So in the medium term, you can do an asset inventory of your OT and IT assets, such as equipment, devices, and processes. You cannot protect what you do not see or know. So in the longer term, use a framework like the maturity model to do a security assessment of your critical infrastructure and remediate the high priority risks. So in summary, we can minimize the impact to our organization if we prioritize the protection of our critical assets. So there are many ways to increase cyber resilience of your infrastructure, and information and intelligence sharing is one of them. So Global Resilience Federation is based in US, supporting 10 ISACs and ISALs. OT ISAC is the latest edition, set up on 1st October 2019, headquartered in Singapore, and support OT operators in Asia Pacific. There's a partnership with Cybersecurity Agency Singapore, but managed independently. I've come to the end of my presentation. I wish you a good day. Enjoy the rest of the sessions and stay safe.